Good day, great 10 learners. Welcome to our mathematics lesson. I am Skulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. Are you ready for today's lesson, grade 10s? I really hope so. Let's be ready, learners. Let's be ready. Make sure that you have your book with you there and your pen and your calculator. We're going to be calculating the surface area and volume of prisms. Okay. Right. So what is our topic today? The volume and surface area, but we're going to concentrate on the effect of K. Effect of K. So a factor, that's a factor, just naming it K, okay? It's a factor. I'll just show you what it is. Right, so that's what we're going to concentrate on. So we're going to use one prism for this because we want to see the effect of K, okay? Right, so at the end of the lesson, you should be able to determine the effect that multiplying any of the dimensions of the prism by a factor K will have on the area and volume of the prism. Let me just explain this. We're going to determine the effect that multiplying any of the dimensions of the prism by a factor K will have on the area and volume of the prism. Right, let's say if we multiply the dimensions of our prism by 2, what will happen to the area of that prism? Is it going also to be multiplied by 2? We will find out. What will happen to the volume? If we multiply the dimensions by 2, what about the volume? Is it also going to increase by a factor of 2? We want to find that out. So our lesson is going to be more investigative, okay? We're going to do our calculations, and then at the end, we come up with a conclusion. You see that? So it's more investigative. So get involved from the beginning, and then we're going to discover things, okay, together, isn't it? We're going to discover things together. So we have to do the calculations, follow the steps that I'm going to give you, and then at the end, we conclude and say, yes, if we increase or if we multiply the dimensions of a prism with this vector, then the volume is going to be multiplied by this vector. Then the surface area is going to be multiplied by this vector, okay? Okay, right. Now, let's try to start our lesson. Right, we have done area and volume. In the previous lesson, we did a lesson on area and volume. So we're going to use that in today's lesson. Just to redo what we did in the previous lesson, I want us to do these two questions. Calculate the surface area of the prism, and then calculate the volume of the prism in 5 minutes. Do both questions in 5 minutes. Then after 5 minutes, we'll discuss the answers, and then we move on to the main objective of today's lesson. Let's try to do this in 5 minutes. Welcome back, grade 10s. Did you manage? Let's do this together. Right, given the following closed rectangular prism, calculate the surface area of the prism. Why closed? Why is it important to have that? Because you can say closed or open. What's the difference between a closed rectangular prism and an open one? Right, so if it is closed, it means all the surfaces are there, the 6 of them. But if it's open, the top part won't be there. So it means that for this area of length times breadth is just 1. We won't say 2 times length times breadth, isn't it? But now when it's closed, it means all the surfaces are there. So you have to be very, very careful. Is it closed cylinder? Is it open cylinder? Is this closed rectangular prism or open rectangular prism? Okay. So if it's closed like this, then all the surfaces are there. So we can use our formula 2 times length times breadth, and then plus 2 times length times height plus 2 times breadth times height. Okay, I will show you the other method. Remember also, we have 2 methods that we can use. And then we just substitute. Now you're marking your work. We just substitute into this formula. You put your dimensions like this, and then we what? We get our answer, which is 700 square centimeters. Did you get it right? If you use this method, please check, and then if there are any corrections that you have to make, can you make them now in 30 seconds? Right, this is what? This is the area you're supposed to get. In 30 seconds, I'm going to wait for you here. Right, I really hope you managed to see where you made a mistake, if there was a mistake. But if there was no mistake, well done. Even if you tried and you got it wrong, you have tried. Well done. Well done. Now, the other method we talked about, we say that we can find the area of the bases, which is this side. If we make this one the bases, remember the bases are the faces that are parallel to each other. We can find the area of these two bases, and then we find the perimeter of the base, and then we multiply the perimeter of the base by the height of the prism. Remember, the height of the prism is the distance between the two parallel faces. Like this is the base here, this is the base here, the distance between them, that's the height of the prism. So now we can do that. The formula was like this. So it's going to be 2 times the area of the base, because there are two bases here, and then plus perimeter of the base, which is this thing, this perimeter which I highlighted here, and then times the height of the prism. We did this in the previous lesson. And then we just substitute into our formula, and then what we get the same answer. We get the same answer, which is what? 700 square centimeters. 700 square centimeters. So this is the area of the bases. Remember, the base here is 10 times 5. If you check this rectangle that I've shaded here, is 10 times 5. But there are two of them. That's why it is 2 times 10 times 5. And then the perimeter of the base is 10 plus 5. And then another 10 plus 5. So we can say 10 plus 5 times 2, isn't it? Okay. Or if you want, you can say 10 plus 5 plus 10 plus 5. Okay, which is what? 30. You see here, this thing gives you 30. If you say 10 plus 5 is 15, 15 times 2 is 30. So the perimeter of the base here is 30, and then times the height of the prism, which is this distance from there to there, and then it's 20 centimeters, then times 20. You see that? And then we get our surface area of the rectangular prism. Right. And then let me give you 1 minute to make your corrections of surface area, and then we go to the volume after that. Okay, let's just get 1 minute. Right, welcome back, grade 10s. I really hope you managed to make your corrections. Well done, well done. If you try to do your work, that's the most important thing. We have to learn mathematics by doing it. You'll never learn by listening to someone. You do mathematics, then that's how you learn. Right, calculating volume. Do you know that calculating volume, I find it very easy compared to the surface area, isn't it? Because volume is just length times breadth times height. You're done. You see, it is very easy to find volume of a rectangular prism. It is length times breadth times height, right? And then that's why we get the cubic centimeters, because we're saying centimeters times centimeters times centimeters, centimeters cubed. You see that? Okay. And then we get 1000 cubed. Did you get that one right? Okay, very good, very good. Now let's go to the main part of today's lesson. I want us now to understand. Remember, what is the objective? We want to see the effect of K, vector K. K can be 2, can be 3, can be 4, can be anything. So we are going to see the effect of this K. Right, now, remember I said the lesson is going to be investigative. At the end, we're going to conclude and say, yes, if we multiply the dimensions by K, to get the volume of the new prism, we must multiply by K or something. Okay, let's see. Let's find out. It's like I don't even know what you are going to get. Also, I'm also part of the investigation, isn't it? I'm also investigating. Given the two rectangular prism, do you see rectangular prism A and B? Okay, right. The dimensions, if I'm saying dimensions, I'm talking about the length of the prism, the breadth of the prism, and the height of the prism. Right, the dimensions of rectangular prism A are multiplied by a factor of what? Want to fill the gap there. To form the dimensions of rectangular B. What we multiply the dimensions of A with to get the dimensions of B? What do we multiply the dimensions of A with to get the dimensions of B? I want us to do that in 1 minute. Try to find the answer here. Look at the dimensions of A and the dimensions of B. What do we do to the dimensions of A to get the dimensions of B? What do we multiply with? It's a factor, so we talk about multiplication here. Let's do that in 1 minute. Right, welcome back, grade 10s. Right, let's check our dimensions. The length here was 4 centimeters. Now the length is 8 centimeters. What did you do? 4 times 2, isn't it? 4 times 2. The breadth here is 2 centimeters. Now the breadth is 4 centimeters. Breadth times 2. You see that? We multiply the breadth times 2. And then the height is 3 centimeters. Now the height is 6 centimeters. So it is height times 2. So now we have multiplied all the dimensions of prism A by 2. So that's the answer I wanted there. So the dimensions of rectangular prism A are multiplied by a factor of 2 to form dimensions of rectangular prism B. Right, do you see that? Now I want to see now, how does the surface area of A change? It changes by a factor of what to form the surface area of rectangular prism B. Okay, all right, let's move on to the next part now. Don't forget this part. The dimensions were increased or multiplied by a factor of 2. Okay, right, now I'm going to give you the areas because we've been doing the calculations, isn't it? Right, now the surface area of A, how do we find it? We say length 2 times length times breadth plus 2 times length times height plus 2 times height times breadth, isn't it? And then we're getting what? We're getting 52 square centimeters. But here I used that other formula where you say 2 times the area of the base plus perimeter times height of the prism. But even if you use that other formula, you'll get the same thing, okay? You'll get the same thing. So I've done the calculations for us here so that you don't waste time. And then for prism B, the surface area is, for prism B, you say we get 208 square centimeters. That's the surface area of what? Of a prism, rectangular prism B. Now, I want you to do this, learners. I want you to find out, what do we multiply the area of prism A with to get the area of prism B? What do we multiply 52 square centimeters with to get 208 square centimeters? Can you try to do that in 1 minute? Let's do it, 1 minute. And then after that, we're going to continue with our discussion. Right, welcome back, grade 10s. Remember our WhatsApp line, learners, 079 454 Please, this number is for us to interact. Remember, you must understand everything we are discussing here, okay? If there's something you have missed, something want me to explain, even this side with a team that is waiting for your questions, we are going to be answering your questions. Please send us your questions or even your input. We are going to be very, very happy when you do that. Okay. Right. Now, remember, let me take you back a bit. We increased the dimensions of the prism A by 2. We multiplied the dimensions by 2. Okay. Now, if we check the surface area of A, what do we multiply it with to get the surface area of B? Did you get 4? Yes, if you say 52 times 4, we get 208. You see that? And then 4 is 2 squared. Right. I want us to try to conclude here. Our K that we're talking about, remember, say the effect of K. In this case, our K is 2. In this case, remember, I said K can be 2, can be 3, can be 4. In this K is, in this case, our K is 2. So if the dimensions of a rectangular prism are multiplied by a factor of K, what will happen to the volume of the rectangular prism? It is going to be multiplied by what? It's going to be multiplied by a factor of K squared. You see that? It is very, very important. Let's say now the dimensions were increased by a factor of 2. Now to find the volume, the surface area of prism B, we can multiply the surface area of A by 2 squared. Okay? Right. Let's conclude now. So we are saying that if the length, breadth, and height are multiplied by a factor of K, then surface area is increased by a factor of K squared. Please write this one down. I'm going to give you 1 minute to write this one down. If length, breadth, and height are multiplied by a factor of K, then the surface area is increased by a factor of K squared. We have investigated and we found out that yes, it is true. So let's write this one down for 1 minute. Right, welcome back, returns. Now I want us to use this conclusion that we came up with. We are going to use this conclusion that we came up with, okay? Right, now, this is the activity. Right, given the rectangular prism, this is the rectangular prism now with different dimensions. Calculate the surface area of the rectangular prism. We are going to do the calculation of the surface area of rectangular prism. And then B, calculate the surface area of the rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 3. Now, I want us to use this, okay, to do B, okay? To answer B, we're using what we have discovered here, right? And then we're going to do A and B. And then when we come back after 4 minutes, we're going to do C and D together. And then we move on after that. So get 4 minutes for you to be able to do A and B. Let's do it. Right, welcome back, grade 10. Let's do AB, and then after that we'll do C and D. Right, so did you manage to calculate the surface area? You're supposed to get the surface area, which was 280 square centimeters, okay? Can you mark that? If you got it wrong, please correct it. That was A. The surface area is 280 square centimeters. Okay. And then we move on. B. Given the rectangular prism here, calculate the surface area of the rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 3. So it means the surface area is going to be multiplied by 3 squared. The surface area is going to be multiplied by 3 squared. So if you say 280 square centimeters times 3 squared, we're getting 2,520. There was no need for us to change all the dimensions or multiply all the dimensions by 3. Okay, so we just multiply the area of the original prism by 3 squared. Then we get our area, the new surface area. You see that? Okay, now C, we want to see if this really is true. So we want to prove this. Okay, that is will be C, and then at D we concluding. Right, so C says, prove your answer for B. Right, we say the dimensions were increased or multiplied by 3. So 10 centimeters became 30 centimeters. 5 centimeters became 15 centimeters. And then 6 centimeters became 18 centimeters. We increased or multiplied every dimension by 3. Okay, now let's find the surface area of this new prism with the new dimensions. Want to see if we're going to get this. Okay, let's see. So we say 2 times 30 times 15 plus 2 times 30 times 18 plus 2 times 15 times 18. Well, I don't need to explain this. I think we've been doing it for a long time. Yes, we're getting the same surface area. Do you see that? Okay, so we can say that in D, if the length and breadth of the height and the height of, sorry, let me read it again. If the length, breadth, and height are multiplied by a factor of 3, then the surface area is increased by a factor of 3 squared. Do you see that? Of 3 squared. So we have done the surface area. Okay, now we're going to look at the volume. Now we're going to do investigation about volume. It will be the same approach that we did with surface area. We want to see now if the dimensions are increased by a factor of k, what will happen to the volume now? Is it going to be k squared? Is it going to be k to the power of 4? Or is it going to be k cubed? We'll find out. Okay, let's see. Now, example 2. Given the two rectangular prism, the dimensions, length, breadth, and height of a rectangular prism A are multiplied by a factor of dash to form the dimensions of rectangular prism B. Okay, we did this in the previous example, so let's just do it together. So if you check, 4 became 8, 2 became 4, 3 became 6. So we multiplied every dimension by 2, isn't it? By a factor of 2. Okay? Right. We want to see now what happens to the volume. What happens to the volume? So now let's find the volume of A and the volume of B. I'm going to show you that, and then you'll tell me now what will happen to the volume of A to produce the volume of B. What do we multiply the volume of A with to get the volume of B? Okay, just that part. Now, the volume of A is like this. Remember, just length times breadth times height. So it's 2 times 3 times 4, which is 24 cubic centimeters. And then the volume of B is going to be 4 times 6 times 8, which is 192 cubic centimeters. Now, I want you to answer this question. What do we multiply the volume of prism A with to get the volume of prism B? Let's try to do that in 1 minute. Right, welcome back, grade 10s. Let's see. What did you find out? What do we multiply 24 with to get 192? Remember, what did you do to the dimensions? We multiplied every dimension by 2, isn't it? Right. Now, if you say 24 times 8, let's see. 24 times 8. 24 times 8. 192. So it means if you multiply the volume of A by 8, we'll get what? 192. And then 8 is what? As an exponent. Is what? In exponential form. What is 8? Or as a product of its prime factors. Is 2 times 2 times 2, isn't it? Which is 2 cubed. You see that? So if we multiply 24 by 2 cubed, we'll get the volume of prism B. So we multiply 24 by 2 cubed to get the volume of prism B. Now, so if we change or we multiply all the volume, if we multiply all the dimensions of A by factor K, what will happen to the volume of K? What will happen to the volume of A? It will increase by which factor? By a factor of K cubed. Okay, right. Let's conclude that. Now we're saying that if length, breadth, and height are multiplied by a factor of K, volume is increased by a factor of K cubed. Okay, let me give you 1 minute to copy this part. Right, if the length, breadth, and height are multiplied by a factor of K, volume is increased by a factor of K cubed. Let's copy this in 1 minute. Right, welcome back, grade 10s. What did you get? Or you're just copying this statement there, is fine. Now, I want us to use this. Now, I'm going to give you all the questions A, B, C, D, and then I'll give you 5 minutes to answer everything because it's just the same as what we did with surface area. Okay, right. Now, using this now, let's answer these 4 questions. Right, calculate the volume of the rectangular prism, and then calculate the volume of the rectangular prism that is formed by after each dimension of the given rectangular prism is multiplied by a factor of 4. I want us to use the statement that you just copied and then prove your answer for B. Remember, how did you do that? So you change every dimension of this rectangular prism by 4, you multiply it by 4 and see if you get the volume of the new prism is going to be the same as the answer you got in B. Does it make sense? I said you multiply every dimension of this prism by 4 and then you'll get your new dimensions, isn't it? And then using the new dimensions, you calculate the volume of that new prism and see if the answer is going to be the same as the answer you got for B. Okay, that is C. And then D, you're just concluding there. Let's do this in 5 minutes. Welcome back, returns. Did you manage? Right, let's do this together and then you're going to be marking your work, okay? Right, let's do it. Right, the volume of the prism, rectangular prism, length times breadth times height. This is easy stuff. 10 times 5 times 6, which is 300 cubic centimeters. Okay? Do you see that these units are not coming from nowhere? Because they're saying centimeters times centimeters times centimeters. That's cubic centimeters. And then, was that A? Yes. And then B, calculate the volume of the rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 4. We say that when the dimensions are multiplied by a factor of k, then the volume we multiply by k cubed, isn't it? So now, can we multiply our volume by 4 cubed? Yes, let's do it. And then 300 times 4 cubed, we are getting 19,200 cubic centimeters, okay? Right now, we want to see, let's increase or multiply each dimension by 4 and find the volume and see if it is going to be the same as this one. Okay, let's do that. Let's do that. Now, these are the new dimensions now. Okay, we've multiplied by 4 here. 6 times 4 is 24. 5 times 4 is 20. 10 times 4 is 40. Do you see that? If we calculate the volume here of this new rectangular prism, are we going to get 19,200 cubic centimeters? Let's see. 40 times 20 times 24. Yes, we're getting the same answer. So this is very true. If we multiply the dimensions of the rectangular prism by k, then the volume is increased by a factor of k cubed. In this case, our k was 4. Do you see that? Okay, I really hope that you have understood this part, okay? But before we go to our conclusion, I want us to talk about something else. Because sometimes, if we check here, we have been increasing all the dimensions. We have been multiplying all the dimensions by what? By the same factor, isn't it? But what if we just change one dimension? What if we change just 2 dimensions? Can I explain this one? I'm not going to give you time to do anything. I want you to listen, okay? I want you to listen. I'm going to be doing calculations and showing you, okay? Right. Now, listen and you can write short notes, okay? Right. Now, we have this rectangular prism, 10 times 5 times 6, which is 300 cubic centimeters. So what if one dimension is changed? Let's say by a factor of, which factor can we use? We have used 2 a lot. Let's say by a factor of 5. Let's just change one dimension or multiply one dimension by a factor of 5. Let's see. Let's multiply our length by a factor of 5. It becomes what? It becomes 50, isn't it? It becomes 50. So our new prism now is going to be having these dimensions. This is our new prism. Is going to be having these dimensions, which is what? Which is 50. You've changed this one to 50. And then this one is still 5 centimeters. And then this one is still 6 centimeters. Okay. So this is the new prism now with the new dimensions. Right, what will happen now? What has happened to the volume of this prism if one dimension has changed? Or we've multiplied one dimension by what? By a factor of 5. Let's see. Before it is what? 300 cubic centimeters. Now the new volume of the new prism is going to be, right, 50 times 5 times 6. What is 50 times 5 times 6? Right, 50 times 5 times 6. And then what do you get? 1,500 cubic centimeters. You see that? So now if you change, if you multiply one dimension by a factor of k, the volume also is going to increase by that factor of k. So we change one dimension, we multiplied one dimension by 5. So the volume also is going to be increasing by a factor of 5. Because if you check here, if you say 300 times 5, we're getting what? 1,500. You see that? So if we change one dimension by a factor of 5, then the volume also will change by a factor of 5, not 5 cubed, okay? Because we only changed one dimension. Does it make sense? Okay, yes. I'll give you time when you're summarizing for you to copy that, because those 2 points that I'm going to discuss now. Now let's move on to if we change 2 dimensions and see what will happen. Okay, don't write anything now. I'll give you time to copy when we are summarizing our lesson. If 2 dimensions are changed, now let's change 2 dimensions. Let's change different ones now. We're going to change this one and this one. We're going to change 2 dimensions. Let's use a factor of 3. Let's use a factor of 3. Right, we're going to say 5 times 3, which is 15, and then 6 times 3, which is 18. So our new rectangular prism is going to be like this. Okay, this is our new rectangular prism now. And then we have what? We have changed. This one is still 10 centimeters, still unchanged. We said we're going to use the factor of 3. So 5 times 3 is 15 centimeters, and then 6 times 3 is 18 centimeters. We have changed how many dimensions? 2 dimensions by a factor of 3. Okay, so now I want to see what will happen now to the volume. Let's find the new volume. Is going to be 10 times 15 times 18, which is equals to 10 times 15 times 18, which is equals to 2,700 cubic centimeters. So now, if we increase 2 dimensions, how will the what? If you increase 2 dimensions, multiply 2 dimensions by a factor of k, how will the volume increase? By a factor of what? The volume increase by a factor of k squared. Remember, we increase the 2 dimensions by 3. So now if you say 300 times 3 squared, can you just do that? 300 times 9, 3 squared is 9. 300 times 9. Do you see that you're getting 2,700? You see that? Okay, so now it depends how many dimensions we have what? We have changed. You see that? So if we change 2 dimensions, multiply by a factor k, then the volume is going to increase by a factor of k squared. If we multiply 1 dimension by a factor of k, then the volume also is going to increase by a factor of k. Okay, right. Now I'm going to give you time to copy the homework. I'm going to give you enough time. I'm going to give you 4 minutes. And then after 4 minutes, we're going to what? We're going to summarize our lesson. Then I'll give you time to copy the summary of these 2 points. If you change 1 dimension, what happens? If you change 2 dimensions, what happens? Remember the other ones we discussed during the lesson, isn't it? Okay. Now, can you have your 4 minutes and copy the homework? Right, welcome back, grade 10s. I really hope you managed to copy the questions. Please do the homework and submit for marking, or even if also you can discuss with your colleagues. That would be fine. Right, now what did we learn today? We say that if length, breadth, and height are multiplied by a factor of k, then the surface area is increased by a factor of k squared. We wrote this one down, so there's no need of what? For us to write it again. Okay? And then we went to the volume. We say that if the length and breadth and height are multiplied by a factor of k, then volume is increased by a factor of k cubed. Okay, that's what we learned. And then we wrote this one down, so there's no need for us to rewrite this. Okay, this is what I want you to write now. The next one. We say that if the length and breadth, or the length and height, or the breadth and height. So here, when you what? If two dimensions are multiplied by a factor of k. So these two dimensions can be length and breadth, or length and height, or breadth and height. So if two dimensions are multiplied by a factor of k, volume is increased by a factor of k squared. This is what I just explained, isn't it? Okay, let me just give you both of them, then I'll give you time to copy. Right, and then the second one says that if length or breadth or height, now one dimension, if one dimension is multiplied by a factor of k, then volume is increased by a factor of k. Okay, these are the two statements that I want you to copy, and then let's do this in 1 minute, and then after that we just what? We just close our lesson. Let's do it for 1 minute. Welcome back, grade 10s. I really hope that you have learned something. Thank you very much for joining us in term 3 lessons, for term 3 lessons. And we're going to meet in term 4, and we're going to continue what? Learning and discovering things. Let's meet in term 4, grade 10s, and enjoy the rest of your day. Enjoy your holidays and take care of each other. Let's meet in term 4. Goodbye.